has done an experiment? Because even within folks on our team, like, who actually has run an experiment before?
Scientists.
Yes, 2. Okay, alright, so that's okay. But the very first question that anytime like people talk about experiments is like, should we run experiments? And usually people fall into 2 camps. There's the like, oh my god, we should run experiments all the day, all the time. And then the group of people who are like, okay, A/B testing, we get it, we're over it. But there are actually like a lot of different facets to really think about when we're talking about experiments. So one thing that I ask when you're trying to run an experiment is, what are you trying to learn from the experiment? Do you want to know why someone is doing something? Why people are choosing the dress that's always in the upper left-hand corner? Or are you trying to figure out what are they going to do and how things are going to change things? If you're trying to answer the what and the how, things might change when you push new product into the market, then running experiments is perfect. If you're trying to understand behavior and the why behind that, then you should probably just stick with user research, user testing, focus groups, surveys, etc. So that's kind of like the big spread between the why versus the what and how. Other questions that people think about and ask is, if I'm doing a small change or a large change, small change is like copy change or removing fields from something, or maybe just like changing button colors and styling, versus site redesign, completely revamping checkout, etc. What of those 2 experiences should we change? And I'm just going to do a vote of hands. Incremental experiments, do you think we should do them or no? Show of hands. Okay, like half the group.
What does hands mean? Does hands mean do them or not?
Hands means do them. Okay, so about half. And then revolutionary change, so site redesign, homepage, or checkout like refresh. Hands to see if you would do it. Okay. Alright, so actually only Jay got it right in that both should be run as experiments. Whether it's incremental or revolutionary, you should be running experiments. Did you? Yes. Sorry, Joe. Sorry, and Joe. And I remembered your name, so hopefully there's some credit there. But yes, regardless of how small a change or how large a change you are trying to make, the best advice is to measure it. Because that's the only way that you'll be able to attribute how much you affected, and also to be able to explain if something else completely unrelated, like broke, or completely unrelated starts like ramping up like crazy. Was it your change that actually affected it? And maybe there was a halo effect that you weren't aware of. Other questions that people think about is, depending on if you're Amazon and you have like millions and millions of page views versus a new startup and you had very few eyeballs and visitors to your site, should you run experiments? The answer there is you kind of have to feel it out, and Thoren will go into this more specifically, but in general, if you'll hit significance or you'll hit directional reads, you should still try to measure it. And even if your product manager or your designer says like, this is definitely the new way that we should build this, it's fine. Like, even if that's going to be the new normal and the new control, it's still worthwhile to run an experiment just to know like how much the baseline has changed. So then there are considerations, because you want to know, what are you trying to learn? You want to learn all the things, especially if you are our CTO, VJ. He wants to know everything all at once, tomorrow, yesterday. But what you want to actually ask is like, what do you want to learn? What are the metrics that you're trying to affect? So if we change the homepage, do we expect that to improve conversion, or do we think that it's going to be an improvement to engagement? If we think it's engagement, what are those metrics? Maybe it's hearting, which is something that we do. If you're shopping along Rent the Runway and you see a couple of styles that you like, you can heart it, add it to a short list, which is basically a favorites list. Does that count towards the metrics? Once you've decided what metrics are, the next thing to do is work with your engineering team, your analytics partners, to make sure that we're actually set up to track it. Because what you'll find is you'll have gaps in your holes. I'm seeing some like head nodding and shaking and laughing because you will be surprised by the things that you realize don't track or that broke with the last update of something and now you need to fix it. Then the next thing to think about is, now you know the metrics, what does success look like? You say that it's going to be harding, so how much does that metric need to improve and lift in order for it to be a success? And then you say it's going to be 20% lift. One thing that's kind of scary but also great for our business is if we put a new offer out there and say it's going to be 40% off your first order, then it blows it out of the water. Everyone comes clamoring to Rent the Runway, and we find logistically we can't support all these sales. Turning over the inventory is breaking things, or we just can't afford the number of turns per dress, whatever it is. Is that a success? If it is, great. Now how do you adjust the business? If it's not, then what's next for you to test? Which kind of gets you to how are you thinking about your roadmap? If you're testing something like Harding, which lives on our product grid, and at the same time you're testing a new customer offer, which might also live on the product grid, testing those two things that happen on the same page or that affect the same metric, those are things that you want to talk out, think about, plan out whether or not you can actually do it at the same time, or actually if you have to stagger it and make sure that you are planning and testing for the most high priority items first, because you might not get to it. We don't have an infinite amount of time or resources, so you want to make sure that you're thinking about your product roadmap. Any questions so far? All right. So one thing that I've got a couple of examples to share. Short registration, this one's the most straightforward. So the one on the far left is the control. Basically, you would come to renttherunway.com and instantly we would pop up a short registration form, except it wasn't very short. It was email address, password, confirm your password, first name, last name, birthday, and zip code. So then we tested two variants. The middle one is email address, password, and birthday. The last one is email address and password. I think some of the audience definitely is, so don't say what won. But what would you think is the winner of this experiment? Three? So...
Show of hands for the first one.
Number three won numbers-wise, but actually what we were surprised by is number 2 turned out to be very comparable. For us as a business, we still went with number 2 because that gives us a data point that's really useful for us. So for example, knowing your birth date, we can, once we have your email address, retarget you around your birthday. Hey, are you going out to celebrate your birthday? Here's a coupon for your birthday. If the jump for number 3 would have been significantly better, I think we would have gone with that. But surprisingly, because they were so close, we kept with the second one, which is what you'll see on our site today. Just some numbers throughout you. So basically, 8% better for the third one and 7% better for the second one. Okay, second test of the group. So we have control, and one of the features that we are considering, or at this point in time we were considering, but right now we're in development for, is social connect. So you want to be able to know what, if anything, we would see in terms of a sign-up rate increase if we offered either Facebook Connect or Google Sign-In. So this was a painted door test. Basically, if you clicked on the sign-in using Facebook button or the sign-in using Google button, we gave you a warm and fuzzy message. Oops, Facebook Connect isn't quite ready yet. Please sign up with your email address. Okay. Now again, show of hands. Number 2 being Facebook. Number 3 being Google. What won?
2.
Well, it doesn't say
Final
Google Plus,
answer?
does it?
What?
It didn't mean, well, I guess it doesn't say Google Plus.
It does not say Google Plus.
Okay, maybe.
So actually, number 3 won, and somewhat handedly. So the surprise there is the fact that, or at least the insight that I think we kind of talked about, and where I placed my bets before we ran the experiment. There was a good bet going around because everyone, like this entire room, said Facebook. But I chose Google because when you think about our customers, if you are planning for a wedding and you're about to rent for a dress, like God forbid when I'm about to rent for the wedding show up in my newsfeed, like that's a scary thought. So I'm afraid that maybe there'll be leakage onto Facebook, whereas Google, even if it went to Google Plus, no one's on it, so it's totally safe. So Google Plus actually won, but similar to what we talked about last time, like what made sense for the business, we actually are working on Facebook Connect right now with Google as a fast follower, because again, I think we found that the Facebook customer tends to be more along the lines of what our business is going for, and we can see a lot of tie-ins with Facebook events and your friends.
What, out of curiosity, do we have stats on the rate people click the X buttons based on what we present to them?
Wait,
The little close.
Click the X always in all the instances, and you can bail. What the potential increase takes into account was both the people who signed up as well as the people who clicked and then bailed. And the reason why we measured it that way is because that's the opportunity, right?
Yeah.
Because if we offered sign with Facebook, or if we didn't offer it and you would have signed up anyway, then that's not really incremental gain for us. So the potential increase here is clicks plus the people who actually signed up. Good question though. If you want more numbers, we can talk about it offline. And then here's a good one, which I can't share any numbers, but I can at least just tell you which one won. So we did a test on our homepage where the hero banner was our editorial banner, which was it's wedding season. And then we wanted to test a value prop, basically for people who are anonymous again. Does telling us kind of a little bit about what we do affect how you feel about us and lead to more conversion? And we had two variants. In case you can't read in the back, welcome to your dream closet was the first. The second was never wear the same dress twice. And the subtitle in both of those cases was choose from thousands of designer looks. And the call to action, different from our control. The control goes to our dress grid, filtered based on the editorial, whatever we're saying is trending. But for the two value prop banners, it actually went to our How It Works page, and that was like one page, simple HTML design to say like love word return, a little bit about like how it works. Nothing fancy because we did this as a pretty quick test. And then here, let's say that dream closet number 2 and never wear the same dress twice is number 3. Show of hands with what you think.
3.
2, 3, 2, 3. Okay, so the 3s have it. In the room, it was pretty even split. 3 won. If you can guess why, at least my hypothesis is again, it's very clear and transparent what the customer benefit is. Dream closet, you kind of have to think, what does that mean? Am I getting a closet? Do I get to continuously like add things to my closet? Whereas never wear the same dress twice is very, very clear of what the value prop there is.
What were the percentages of that?
I can't share the percentages here, but what I would say is not only do we see higher sign-up rate between both of the value prop banners, they also both had higher activation rates within 7 days compared to our control. So surprisingly, adding friction to product when it's the right friction helped us.
Do you try to avoid these small things like that one's in all caps and that one's in lowercase?
So we did think about that in terms of like how much that would affect the experiment and purity. Purity-wise, yes, that is a difference, but we went with it because copywriting-wise, it doesn't make sense to have like the sentence "never wear the same dress twice" in all caps. So yes, that's definitely something to think about, and you can kind of like argue and discuss like how pure you want to be, because we often are running like other experiments sometimes that are orthogonal to whatever is running on the homepage. We take liberties as long as we're aware of what those differences are. Cool. Anyone else? And then some tools in case you guys are thinking about doing some experimenting yourselves. The experiment calculator, which was created by a guy who I used to work with at Etsy. It basically, you kind of put in your inputs, which you'll need to know about your own site and or app activities of eligible visits, the percentage of people that you want to put into a bucket of like the different experiment variants, and then how much, when it says current conversion rate, if it happens to be registration, it's the sign-up rate. That's what we talk about when we're talking about conversion. And then how much you think you'll affect it. Will it be a 5% lift? Will it be a 5% decrease? And then 1%, 95%, and 80%, you kind of can, 95% and 80%, I basically leave those alone since that is typically what we use for just like standard confidence in our experiments. Next tool is Alchemy, but I'm not going to go into that because Jean is going to go into that in depth. And then Treatment Selector, which one of our front-end engineers created, which is an awesome tool. Basically, it leverages what we already have on the back end to the front end, so we can force override the different experiments that we have. So you can choose as product people, QA who's testing, or our customer service reps, the customer insights team. If they're trying to see what our customers are seeing, they can force themselves into an experiment variant, which we found to be super helpful. Experiment dashboard, which Thoren will get into in depth. And lastly, the StatSig calculator. I like to use getdatadriven.coms because it's dead easy to use, and it says with specificity on like the confidence level, how much what the level is, the p-value. So that's the one that I like, but there are many out there. I think that was it for me. Do you guys have any questions? We'll stick around for a little bit afterwards, but
Try to hold questions to the end.
Sure.
I think that's really
cool. And now they always say when you're doing a presentation, you should like warm hand off to the next person. Go for it.
Alright.
That way really hot.
It is kind of warm.
The AC's
Sorry, guys. So I'm going to talk about Alchemy. So Alchemy is a project I worked on here at RTR. It's an open source project. What is it? It's a Dropwizard service. So it's a Dropwizard meetup, so I guess it kind of ties into that. So it's a Java service. Basically, its function is to allow you to define your experiments and then have it divvy out which treatment a user should receive on the site. So should they receive the control treatment? Should they receive some other treatment? And so forth. So some of the requirements that the service had to fulfill was treatment assignment needs to be flexible, so it should be really easy to say I want half my users on this treatment, the other half on the other treatment. Easy to configure. Consistent, so if tomorrow, if I'm in control, when I visit the site tomorrow, I should still be in control. Your treatment that you're assigned should never change. Ideally, it should never change. Should be fast, should be really quick to query the service and say which treatment am I in. Equally distributed, which kind of goes along with consistent. If you say 50-50, it should actually be 50-50. It shouldn't be 40-60. And overriding. So similar to the screen you saw where you can select which treatment you want, it should allow for that to be configurable as well. So you should be able to have special cases for testing. So before Alchemy was written, there were two sort of incarnations of experiment service, as we called it. Both had different pros and cons. So the very first version, basically, the way it worked is I don't know if exactly this is how it worked, but I believe you went on the website for the first time. It would then pick for you what treatments you should be in, and it would then persist that into a database. So for every single user that visited the site, we would store what treatments they were part of. And I think there was some kind of cron job that would run and fill in any missing gaps. Like I guess if you add a new experiment and you haven't visited the site or something like that.
We had I can talk. So when we added
Wait,
that,
what's your name and what do you do?
Who are you?
I'm Vaibhav, I work in the analytics team at Random. So back when we built that version of experiment service, we were also a closed site, so everyone needed to log in. So we knew the user ID of every user. So that service used to, on a nightly basis, allocate the treatments for every single user in our database, and then on the side we would just use those treatments.
Okay. So yeah, so that's how that worked. It was persisted to a database. For every treatment and every user ID, there would be like a row in the table somewhere for that. So the pros of that were, you could tweak which treatments you received if you wanted to. And if you decided to change your treatment allocation, let's say from 50-50 to 40-60, it wouldn't necessarily affect users you've already given treatments, because you'd just be changing the strategy for allocating new treatments to new users. The downsides were you had to read from the database, maybe. If you're doing caching, you'd probably have to cache thousands of rows, and it would only grow as the number of experiments and the number of users who were visiting your site grow. So that was not quite scalable, and as Bob mentioned, you can't handle anonymous, or you couldn't handle anonymous users in this first version. So then came the second version. So it uses hashing and bucketing users into a treatment. So you could take your user ID, run a hash function on it, modulo 100, and then put you in whatever bucket, 0 to 100 or 0 to 99 that you belong to, and then each one of those buckets would be assigned a treatment. So if you wanted 50-50, then maybe 0 through 49 would be control, and 50 through 99 would be your non-control treatment. Pros of that was it was fast, it's really easy to hash. You don't have to read it from a database. Memory footprint is really low. You don't have to cache rows, you just have to cache the configuration. And this version could handle anonymous users, and the way it did it is through a thing called browser ID, which is basically when you visit the site, for the first time we generate a UUID, and then we store it in a cookie, and then future visits will use that UUID to identify you until you log in or register and log in. The downside of this is that if you change your treatment allocation, you may affect existing users. Because if they hash to bucket 50, and now 50 is a different treatment, then they may get a different experience. So then third generation, which is Alchemy, uses the same strategy, but it has a lot of extra features. It's easier to configure than the previous one. It supports treatment overrides, so I can say, for this experiment, I want user ID 1000 to receive treatment 1, instead of hashing the user ID, figuring out which treatment to get. It has some advanced filtering options, so you can say whether a user is in a treatment or not based on certain criteria. And then there's metadata endpoints, so the service sort of can describe itself. You can figure out what kind of things you can filter out. I'll get more into that. So how does it work? So usually it starts off with front end. There are some Java services that use experiments, but it's usually the front end. So the front end has some identity. So they have some structure that identifies the user on the website. What we use today is just their user ID and their device ID. If they're not logged in, there is no user ID. We've toyed around with the idea of using IP address, maybe using some kind of geolocation thing, so that's a possibility. So this gets sent to Alchemy. Alchemy then takes this data structure and basically flattens it and generates any additional attributes that might be useful for filtering and for hashing. So it might take something like the structure and create, user ID, device ID, IP, those are given, but maybe it'll geo-resolve the IP address and figure out it's an East Coast IP address. So it sets an attribute called East Coast. And anonymous is false because they have a user ID. So they're not anonymous, they're logged in. So next, once this flat map of attributes is generated, you have a bunch of experiments you have configured. And for each of these experiments, you can have a filter, which determines whether you're in the experiment, and a hash, which says, what should I hash on? So as a good example, let's say that you can only check out once you're logged in. So if you have a checkout experiment, it probably wouldn't make sense to have an experiment apply to anonymous users. So in that case, you may want to have a filter of not anonymous. So essentially what that would mean is, if this is the identity that's passed in, it will, if you have a user ID, it will include that experiment. It'll then give you a treatment for that experiment. So if we look at the filter conditions, the first two apply, the last one doesn't. So because you're not anonymous, you're not part of the last experiment. So going further, so let's take a particular experiment, the new checkout experiment. You've met the filter criteria, and it says to hash on user ID. We're going to uniquely identify you by user ID. If it were an experiment for an anonymous person, we would probably hash on device ID, because that's the only uniquely identifiable thing we know about you. So we'll hash on user ID, maybe modulo 100 or 10 in this case. So we figure out that you should belong to bucket 2, and so this is a treatment we receive, basically. So this is a 50-50 experiment where you have a half and half. And it should be noted with the distribution requirement, because we're using a hash function, I think SHA-512, it has good distribution, so it meets that requirement. You may have also noticed there's like filter expressions. So it can be used for two things. One, as I showed, was experiment filtering. So you can include and exclude users out of particular experiments. It can also be used for user override. So if I wanted to create treatment override, if I want to assign myself to a treatment, I can say add an override with the expression user ID equals 7389252. Give that user treatment 1. And then whenever it gets treatments for me, I will get treatment for that experiment.
Which is useful for QA.
Yeah, very useful for QA. I don't even remember. So actually the current treatment switcher thing actually doesn't do anything in the back end. It's just a JavaScript hack, basically, for now. Eventually we'll want to have it leverage overrides in the back end. And that's the only way we've been able to affect or override user treatments. It's by the client sort of faking it out.
It's a real cool DSL.
Yeah, so this was implemented using Atlas 4. So it just has a very simple grammar file that says, this is what the filter expression looks like. And it allows you to do stuff like you can nest Boolean conditions. You can do ORs, you can do ANDs. You can use a pipe symbol for OR, you can use the word OR. You can use the word not. You can do equality, inequalities, comparisons. Just like a basic, simple filtering expression language.
It can also be used for evil when front-end devs want to force the designers or product people into a specific variant, just so that we are always looking at the same thing. They haven't done it, but the threat is there.
I mean, an interesting thing you could do, like if you convert an IP address into a geolocation, you could theoretically create a treatment override that says, I want everyone in New York State to receive this treatment for whatever reason. I don't know why you do that, sure. Just to be clear though, Alchemy doesn't implement the mapping of IP to geolocation. That's left up to whoever wants to use the framework. It's just a suggestion of what you could do with it. Some other features, flexible data store. So it implements Mongo and in-memory. In-memory is kind of cool because you can actually spin up the service, use an in-memory store, which is just a hash map, and you can write unit tests that will actually exercise the whole service. Mongo is what we use in-house for storing the configuration of these experiments. And this service does not track experiments, it only stores the configuration for experiments. For tracking, you have to, for now, do some other thing. Thoren will get into that. We use overrides, as I mentioned, RESTful API, and documentation.
You got a question?
Oh, so
How does it solve the reallocation process problem?
So it is still a problem. If you are reallocating, you can still potentially skew your, it's not so bad if you, try to explain it a good way. So let's say you start with an experiment, you start 50-50. So you have, you're recording your results for that timeline, and then you decide to change it to 25-75. Yes, 25% of your users will now be in a different treatment, but you know for sure that it's 25-75, whereas in the other solution, changing it to 25-75 doesn't mean that it really was 25-75, because some existing users were already assigned treatments with the 50-50 rule. Now you're changing the rule. Their treatments may not change.
On the new users?
Yeah. It does make allocation a little easier. So the way it does allocation is sort of like a file system where when you allocate treatments, it'll try to fill in any empty space. If you deallocate something, it'll just wipe out however many units you want to deallocate. And then anytime you allocate more, it'll try to fill in empty space first. Well, it won't let you allocate, over-allocate. So there's allocate, deallocate, and then there's a function called reallocate, where you're explicitly deallocating from one treatment and reallocating to another. Which, at least then you know exactly what your expected outcome is in the end configuration.
We use that pretty frequently when we're going from a control to winner. If we want to move people from control and reallocate them into the winner, we'll use reallocate instead of deallocating and reallocating.
Yeah, because it's not quite, deallocating and allocating is not the same as reallocating, because you could end up filling empty space rather than the original space the deallocated stuff occupied. That's the best way to explain it. Yeah, so that's it. Any other questions?
What happens when anonymous users become actual users?
So that's a hard problem that we haven't really solved yet. So you're asking about an experiment that could apply to both anonymous and authenticated users? Yeah, I think one idea we were toying around with is somehow, well, in that case, what we would probably do is just rely on device ID, because you always have a device ID. Sure, it may change from browser to browser, or it may change if you clear your cookies, but it'll at least be more consistent once you do log in. Another idea was to somehow track for a given user ID what browser ID they had, but I don't know how that would work. Just somebody brought this up, like we were thinking about this. They didn't go into the details, so I'm not exactly sure.
One way we handle it is analyzing it after the fact. So you observe all the users who got the treatment. So suppose for a given user they have 2 devices, and you can see within those two devices, did they get the same treatment or were they exposed to different treatments? So then when you are analyzing, you filter out those users who saw different treatments.
Say like contaminated.
Is there a use case that you were thinking about or had in mind?
Like a lot of experiments are like trying to like stories converted.
I mean, like the hero page is a good one. You see it whether you're logged in or not. So I think we just default to device ID.
Yeah, we kind of assume that even if you are cooking for our experiment purposes, if you're not signed in, we treat you as an anonymous customer versus a user. One thing that we've been kind of thinking through, if it gets like to create a really muddy customer experience, is if we test for anonymous customers, a new offer. Our current offer right now is $25 off of your first rental with a $75 minimum. But what if we gave you $30 off another minimum offer? You might see $30 experiment as an anonymous customer when you come in. If you then log out again, you might have to see 25. Kind of don't really do too much to address that. And frankly, I haven't seen customers be so aware of differences that it's been a problem at all.
I guess another one could be IP address, although it's probably even less
It's
reliable.
aggressive.
Huh?
It's aggressive.
Yeah. All right. Cool.
I'm sorry, I have a question.
Oh, yeah.
So what made you guys go this route versus using something like Signal or like a more like kind of like enterprise analytics like platform that kind of has all this built in like AdBlocks?
So you mean for the tracking portion?
Tracking, I mean, and a lot of those products have like A/B testing and like allowing you to do things like treatments.
I'm not sure. I just the main reason I worked on a project is just because there was a lot of friction to use the existing system. It was really hard to configure. Yeah, I guess we just hadn't looked into other third party. We figured it was kind of simple enough that it didn't need to be an enterprise solution, maybe. Like, I don't know if we use it enough.
Is there like a time commitment, like development wise, to get this like, what kind of time commitment is involved in getting to this point versus, you know,
I mean,
like
A few
hundreds of
months.
hours, like,
It was a few months.
okay.
Yeah, it was a good amount, but I think the payoff was worth it. Like as of late, we've been just doing crazy amount of experiments versus the past. Because in the past, it was literally like,
Sorry.
I need to configure an experiment, and I'd have to sit down with a person, and it'd probably take like an hour to configure an experiment, which shouldn't be the case. Now it takes like 2 minutes. It's definitely worth it. And we also, the thing about this service is, so you have Alchemy, the open source project, and then we have Alchemy RTR internally, which just consumes that open source project. We needed that to behave the same way as the old experiment service. So that way it wouldn't be too difficult. So we emulate the old endpoint we used to hit to get treatments, and it works the same way, it hashes the same way. So it needed to be flexible enough for us to override the default hashing behavior so we could support the old. So that way treatments don't just change when we switch over to the new service. So that might have been another reason.
It also might be quite possible that when you first evaluate these things, those products won't be marketed, and then by the time that the existing technology wasn't like meeting our needs, it just made more sense to fix the part that wasn't as flexible to build it out. Like I said, this was like a 2-month project with one person we were working on.
We also kind of wanted to get our name out a little bit for an open source project. So that was another motivator.
One of the challenges that I had with enterprise solutions was most of them do not pass the granular treatment information, because for any experiment we like to do a lot of granular analysis and break it out by new users, repeat users, devices, etc. So we actually worked with one of them, Maximizer, for a little bit, but we were not too happy with that solution.
It's not the same thing at Etsy. It was just like, felt like if you home grow it, and if you have time, the team to home grow both the setup for the experiment and the analytics to support it and read it afterwards, you keep all the data in-house, so you can slice and dice however you want.
Yeah, I find like a lot of times you try a third-party solution, then eventually it hits its limits, and then you're like, why don't we just, I don't know, if it's simple.
I think also too, we like a lot of the software for Power has to be custom, just in general, because you can't buy off the party, off the shelf software to support like a dress rental business. There just aren't people doing this sort of thing. Right. So I think in general, we evaluate software, but a lot of times it's like, we're so used to having the right on thing that it's not as big a deal.
Right, you can ask that question again with Thoren's because his also was another piece of work to build and then support online.
Build and support what?
To support ongoing.
Okay.
So yeah.
All right, any other questions? All right, let's last question.
No warm handoff high five, G?
I'm sorry, I suck at gifts.
Work on the analytics team. We're going to talk about, okay, so basically all of this experiment talk is interesting. We've got some bucketing instrumenting now. What do we do with this bucketing? It sounds cool, let's do something with it, right? So we'll show these slides later and you can read through some of these comics. I do some GIFs to kind of keep it going. But we're basically going to A/B test. That's the whole point of bucketing. If you have a simple question, you say, hey, what would happen if I did this? And you're maybe at a Burger King somewhere and you see oh, that's really interesting. I wonder why they chose to make the menu look that way. And then you think, well, there's no way they're going to get inside my head, so tough on them. Well, it's actually interesting. If you say, well, half their stores have one menu and half the stores have a different menu, let's see which sales change over time, you're running an A/B test. So on our website, it's actually really easy to instrument. There's just a couple things that you have to meet in order to be able to run these experiments. You want to do randomized bucketing. So if, in this case, we'll talk about 50-50. I expect half the users who show up on the site to experience one treatment, we'll call it control, and the other one will receive a different treatment, test, which will just be one variable changing on the site. Melinda gave a lot of examples of what that looks like. In that case, I want to, if you just think of a spectrum of people, 100 people show up, 50 should end up in one, and 50 should show up in the other. One thing Gene didn't talk about that was kind of cool is if you give it a different experiment, let's say it's as naive as saying a hash on a user ID. User ID 1 will always end up in the same treatment if you do a mod on that. So what he did is he changed, I think, the seed or the index.
There's a seed. Yeah, by default, create a new experiment, adds a random seed.
Yep, so each experiment will have a different seed, so therefore the distribution should land everybody meeting the requirement of it being random in that bucketing. If you don't, consider that in your bucketing, you're going to end up having, 50-50 tests where these 10,000 users, 5,000 always end up seeing the exact same website. The other 5,000 are like, what the hell's going on our website? This thing is just changing all the time for me. So this way, we kind of spread the love. Another thing, even distribution. So when we say, I set it up to be 50-50, even though that's random and by chance, if 10 people show up, all 10 could end up in one treatment. Over time, we want to see that converge to or regress to the mean. So we should see a 50-50 distribution over time. So one thing I explained earlier was when you do a user ID mod 2, that's terrible, you should hash on it, and then to even top that off, you throw in the seeding, so you switch it so that the user ID doesn't always get the same hash or the same value. Deterministic assignments, so we kind of talked about it, but just to really beat that over the head. If I show up to the website and I see a new redesign, let's say it's one of those revolutionary experiments Melinda was talking about, I want to see that experience, and then I don't want to see the old version the next time I show up and then go back to the new one. You get contaminated data, and it's just really, really a bad experience. You can't look at that stuff. It gives a bad user experience, so it's trash both ways. So we have to have it to be deterministic. Every time a browser shows up, every time a user shows up, it has to be very consistent. And the groups must be mutually exclusive. They can't have one person who gets to straddle both back and forth. Those people somehow make it into our data set and we just clean them out when we do our analysis. And I don't know if I'm cut off, but I think that was last bullet. Okay, so all the bucketing stuff's all set up, right? What do we do with it now? So here are a few things that we're going to do. We're going to log it, then we're going to analyze, pick a winner, and then go on to the next thing. So, all right, let's talk about our logs. For us, we call it pixels. Other people call it events. They're basically just actions that happen on your website. You're going to take all the user actions and collect them in a nice server. That server is going to have a whole mess of data, and then you're going to have to be able to clean it up one way or another. This talk is really not about the ETL process of doing that, but that is a huge part of this project. So again, we're going to collect all the user information. The user information is going to have basic stuff. I hit this page, I added to cart, I signed up, I did it at this time, this is my IP address, this is my user ID, and some additional attributes would be the experiment I was in, what device I came from, all that stuff. So hopefully everybody in the audience is familiar with the stuff that can be collected by visiting a website. You should assume that they are watching everything, and the better ones do watch everything. And the worst governments watch everything too. So you parse it into a readable format after it's been collected, and then you have to load it into a data store. If anybody's interested, we use Vertica to do all of our analysis after the fact. So it's a big columnar database. We stick it in there, and it seems to really fit the bill for us. It's really worked well. In this example, we're going to talk about the transformation of data once it's made it into our database. The simplest way to describe it is if you took each of those pixels, each of those lines that you hit from the server, and you serialize them. So you group them on user, you group them on browser, whatever attribute that we're trying to get, and then you sort it by time. You have your rules, and you create these visits. So now you have this concept of a visit, which we all know is like you hit the website, all your actions in a single session. We call that a visit. We follow the same rules as GA, so nothing fancy there. And then some examples of what a visit could look like. You hit the home page, you register, you add to bag, and then maybe you bounce. Versus you enter, you hit a product page, and then you immediately bounce. So this is a real bounce. And then there's other people who maybe come through, they see a wedding page, a product page, they register, add to bag, order, full shebang. So that's like the ideal scenario. What that looks like in a more data structured format is you'll have something that kind of continues to tabulate the information like this, and you want to continue to collect binary responses. Binary response being that they signed up, they came back to the site, they hit X number of pages, time on site, met this goal, or that they placed an order. So now that we have it nicely aligned, we're going to go ahead and analyze our results. First thing you want to do is validate that the data makes sense. Yep.
So back on the last slide, do you maintain the order that the visit happened in?
Yeah, we have a timestamp for every single line that's in our pixel server, so we can tell which pages you saw in which order.
In the table, you just store the numbers, right?
Sorry, for this crude example, it is, but if you had an interesting funnel that you wanted to see, you say, I want to know who hits this page, then sees address, then picks a date, does X, Y, and Z. All of those things you'd have to analyze, but then you still should convert that into a binary response. All right, so then before you make any decisions on who's the winner, you got to validate to make sure it worked. So if you said it's got to be 50-50, and the results come out 60-40, something is biased. Maybe somehow you let bots in, who knows what, but your data is pretty much going to be trashed. If you can't fix the outliers, you really should rerun your tests, fixing for that bug. That's really important. Then you want to make sure if there were any eligibility requirements for these users. So it had to be on desktop. Make sure that all the traffic isn't coming in from mobile, because then you probably reverse the eligibility requirements. Only people on mobile were being bucketed, but actually not rendered the experiment. So now you end up in a state where you're trying to read it, and you're like, none of this data is making any sense. Conversion didn't change at all. So you want to make sure that whatever eligibility you set is consistent. And then, without having seen the results, you just want to make sure that your site doesn't crash, 404s don't go up. You're still getting orders, immediately after you flip the switch and you threw it on. Okay, so now we're getting to the point where we can actually have fun with the data. When you look at it, you say, okay, well, control is the truth, right? This was the website before we ran the experiment. Whatever these numbers are, the variance that we tested for, did they have a difference? Whether good or bad, but it's, hopefully you're aiming for an increase in whatever your metrics are. If you see that there was a change, yep.
You said before you're like spreading the love of different experiments on different groups of users. So how do you have like a control experience if